Okay, welcome to Elementary Statistics. It's our Intro to Stats class, Math 1114, and I'm Merrick. We're going to be talking about Section 1.1. This is going to be Part 1. I'm not sure if we're going to need to go into two parts. If we do, I'll make sure I label that very clearly. All right, so stats, we're going to work on an overview today. It's kind of the first big pictures, bird's eye view kind of discussion about statistics and what it does and how it can be used. All right, so the idea of statistics is we find information, we analyze it, and we can draw conclusions from it. So statistical thinking involves critical thinking and the ability to make sense of the results. And I want to point out that all of this is stuff that nobody else sees. This is the work part of the statistics. And then at the very end, we talk about the results. And so it seems like people are just kind of running around saying statistics. Actually, there's a lot of work that goes into it before that ever happens, before there's ever any publishing or publication, publicizing of our results. So it requires more thinking, and computation is less key in this particular math than it is in other maths, but it is important to be able to do the math, so be mindful of the arithmetic that you're going to have to do. All right, so data. Data is both positive, both the singular and the plural. Okay, so this is data. It can be used as both. Okay, so it's a collection of observations or measurements or some other thing that we have decided that we're going to measure. Okay, so that becomes our data. Statistics has to do with the science of planning studies and experiments, obtaining data, organizing, summarizing, and presenting, analyzing, and interpreting those data, and then drawing conclusions based on them. If you take a look, all of this stuff, up until the time we're talking about drawing conclusions based on them, all of this stuff is kind of behind the scenes. This is all us doing the work. And then finally we get to the conclusion, right? All right, the population is everybody in a certain group. If you were to say every person who is a student at ARCC, that would be the population. Assuming that my class is truly random, then we might wind up being a sample of the population. Okay, we'll talk more about that in a little bit. So that the population is everybody, right? It's all of the data that could be considered. All right, a census takes a look at the population. It is looking to have the entirety of the population. I know we just had a census in 2020. The government uses that to help us determine where things like hospitals and fire departments need to be placed, and how many schools they should build, and so on. So they're looking to find every single person and ask them to kind of declare themselves on where they live. The sample is a sub-collection of members of the population. So as I said, the ARCC, everybody who's a student at ARCC might be the population. And then this class would be a sample because we're a small group. We're a subset of all of the students that attend ARCC. So here's a case. They have the example using residential carbon monoxide detectors. And this actually happened. There are 38 million carbon monoxide detectors installed in the United States. 30 of them randomly selected, and random is important. So randomly selected and tested. It was found that 12 of them failed to provide an alarm in hazardous carbon monoxide conditions. All right, and like I said, that randomly is going to come back and get us. This is going to be the piece that we're going to deal with a lot. All right, what happens next? In this case, the population and the sample are, well, the population is the 38 million carbon monoxide detectors in the United States. The sample is 30 carbon monoxide detectors that were randomly tested or selected and tested. So the objective is to use the sample data to give us the basis for drawing conclusions about the population. So just that small number of carbon monoxide detectors gives us a pretty solid picture of how these things are going to behave in general. All right. All right, so here's a kind of the process that happens. And if you take a look, there's a whole bunch of stuff that happens until we get to the conclusion. And the conclusion, like I say, is that's the only part that most people see. All of the stuff that's in the kind of a teal covered box and the kind of yellow orange box, those are all going to, that's all of the work that we do to get there. So context, what does the data represent? What is the goal of the study? Source of the data, we're going to look at that. Sampling method, how do we pick our data in a way that is unbiased, and so that that we're aware that it is biased. Next, we go on to analyze. We're going to graph the data, see what it looks like, see if we can find out what the pattern is. Explore the data. Are there outliers that would be numbers that are really far away? Important statistics, summarize the data. So what is the mean, median, mode, standard deviation, range, all of that stuff. How is the data distributed? Is it a flat line? Is it a bell curve? Is it a couple of curves? What's going on with it? Then we're going to apply statistical methods. We're going to use the technology to obtain the results. And then we're going to use all of this stuff so far to give us the results of statistical significance and the results of practical significance. All right. So we'll talk more about some of these here in just a second. Here we're having the pleasure boats and Manatee fatalities. We're trying to see if there's a relationship between the pleasure boats and how many Manatee fatalities there are. And this includes information of the registered pleasure boats in Florida. And that's, over a number of particular years, right? It's given, the format of the table suggests the following goal, that there's a relationship between the numbers of boats and the number of Manatee deaths from boats. Then we're going to look at the source of the data. The data in the table is from the Florida Department of Highway Safety and Motor Vehicles and the Florida Marine Research Institute. Those are pretty cut and dried, statistical, don't have any kind of vested interest in anything. The sources appear reputable, right? We're looking for good data as opposed to whatever someone wants to throw our way. Our sampling method, the data was obtained from official government records that are known to be reliable. The sampling method appears to be sound. So we're going to go with the fact that it is sound and be able to go from there. We're going to use that information. At that point, we would do some of our mathematical tests and see how it behaves to see if we have a curve or how is it behaving, and be able to move forward with making a conclusion. All right, so a voluntary response sample or self-selected sample, that would be people deciding to include themselves into the survey or the sample If you're ever walking through the mall and somebody stops you and says, will you answer questions for my survey? And you say, thank you, no. You have now self-selected out of that survey. If you have put up a poll on Facebook or one of the different chat groups, different social media groups, and you ask people, your friends, to respond, and the response you get is a voluntary response sample. And it actually excludes a bunch of other people who don't have internet, people who aren't online at the time you pose the question. A lot of things go into whether or not that's a good set of data or not. All right. So our voluntary response is probably less than ideal. It is not the best data that we can have. So here's common examples of voluntary response. A couple of common examples of voluntary response samples. That's a mouthful. So this is where, people choose to do it or not, and it bends our information pretty dramatically in one way or another. And I'm actually going to stop at this point. I want to pick this up again here in the next video, but I wanted to make certain that we're going to take a look at the fact that this is probably less than ideal in order to get our data.